This time for our screen recording, I am going to take a moment to show you for chapter 5 and potentially 7, 6. There will be times when you will be doing normal distributions. We start them in chapter 5, where Excel and or StatCrunch can be helpful. Personally, I still sometimes like to use the chart, the Z-score chart that will be made available to you on our portal. So, because I like the visual that exists when I'm looking at how the probability moves over time. I want you to remember that the Z-score chart, which is the first thing that we will see together in videos or PowerPoints, always quotes the probability to the left. And that's super duper important, always quotes to the left. So I'm setting this up to always quote to the left for the normal distribution as well, at least in Excel. So I wrote the formulas here. This is not me doing the formula, it's just a little bit of notes. In Excel, we can use a formula, and I'll do an example here, where let's pretend that we have our standard normal curve, which is the mean is 0 and a standard deviation is equal to 1. And let's pretend that we wanted to find a probability. So the formula you're going to use is equal norm.dist. And you notice when you open, it asks you for the x you're looking for, the mean, the standard deviation, and cumulative, where for consistency's sake, I am putting true because it's going to quote everything to the left. So let's pretend we put in an x value of -1, which would be a z-score of -1 if we're in a standard normal table, with a 0 mean, a 1 standard deviation, and a true. And if you remember, based on our empirical rule, you should be able to see here, it's only about 15%. Remember that the empirical rule had 68% is within 1 standard deviation, and therefore to the left was about 16 and to the right was about roughly. And you can look at the empirical rule chart to be sure there. The other formula, well, let me skip over to StatCrunch. If we go, because we can do the same thing, if we go to StatCrunch, then we'll have a nice visible. We've shown you before that if you log in with your credentials, you can go to Stat, Calculate, and last time we did binomial, but now we're going to go down to normal. And I'll drag this over here so you can see it. And the normal distribution with a mean of 0, which we just said, a standard deviation of 1, and we said we were always going to look at the left, so less than, let's put in -1, and it will show us the visual. So we would have known that 68% was this line to this line. Anyway, you can see here. So you can also, by subtraction or by the complement nature, say that the opposite would be 84%, which should also feel okay. The neat part about StatCrunch is that you can also click on this word, between, and then you can look between two values. So between -1 and 1 is about 68%. You might remember from one of our PowerPoints that we talked about the normal distribution just being the empirical rule with more precision. And that's exactly what this gives you here. I don't have a good way in Excel to do this between. There probably is one that I just haven't used because I love the visual that is StatCrunch. The other thing that is available in Excel is this norm.in or inverse, where you could do the exact opposite, norm.inverse, and you can say, I have a probability, and let's pretend it was 84%. 84% with a mean of 0 and a standard deviation of 1, it's going to come back and tell you that z-score, which is just about 1, which makes sense at 84%. If we were back over here and we did less than 1, it would be about 84%. So the normal distribution gives you a probability. The norm.inverse takes a probability and works you backwards, both of which are good. The StatCrunch, however, is nicer because you fill in what you know and it will give you what you don't know. You don't need to know two separate formulas. You only need to know one chart, fill in what's known, and it will give you what's unknown. In both cases, I have used a mean of 0 and a standard deviation of 1 to build our standard normal, but you can use the mean and standard deviation of whatever problem you have, which is super helpful. You don't have to do all the calculations of z-score if you don't wish to. Hope you find that helpful.